we can write dynamic pattern data regressions as like I have written in equation 2. So the first one is as usual panel data regression model where yi is dependent variable, x are vector of all explanatory variable, alpha is unobserved factor, and epsilon it1 is idiosyncratic error term. So in a basic panel data regression model, uh, this one is the composite error term where alpha I plus epsilon it, and in a case this alpha I is correlated with any of the explanatory variable, in that case we get bias and inconsistent estimates. And for getting right of that problem, we run a basic panel data regression model, use either fixed or random effect. In a dynamic case, since we write a dynamic regression equation model as like this, so this one is the autoregressive at pth order. So YIT is as usual dependent variable, I is cross sectional unit, T is time period, gamma 1 is the coefficient value associated with the YIT minus 1. So in a dynamic case, we will have lag value of dependent variable as an explanatory variable. So when you are having only one lag value, that one is autoregressive at order 1. So we'll have only one lag value of dependent variable as an explanatory variable. For a higher order, for a pth order, we can say, let's say that this one is the row instead of pth. For rowth order, this would be become r rho y t minus rho. And xit as usual vector of uh, remaining explanatory variable, alpha is unobserved cross-sectional heterogeneity, and this one is idiosyncratic error term. Since you are having a row lagged value, so in that case we lose row number of observations. So the number of observations remains with that one is rho plus 1 to t. Objective is here to constantly estimate all parameters value, including row. In a autoregressive one case, we can write dynamic panel data regression equation like this, and t here starts with 2 to t. So we know 1, 2 to t. Again, why 2 to t? Because we lose first observations when we take a lag value of any observation. So since here you are taking n lag value of any variable. So since here you are taking a lag value of dependent variable, so we lose one observation for all variable. So the number of observations remains, that one is 2 to t. So for convenience, we work with the only first order dynamic panel data regression model, and the assumption of these models are, we assume that your panel data one is short panel data, row value is less than 1. So absolute value of rows, which one is the coefficient value of yit minus 1, is less than 1. It is so because if we assume equal to 1, then the effect of yt minus 1 persists over a period of time. And similarly, if it is greater than 1, then the effect of yit minus 1 on it, and it goes uh, along, and it effect of this goes up when you move ahead with the time period. So ultimately it explodes after a period of time and it become infinity. So because of that reason, we strictly assume the absolute value of this particular variable must be less than 1. And that one is the condition of stationarity condition. If you are having a 1, then uh, the data set is called non-stationary data set. And in that case, we require to convert data set into the stationary form data set. So with the large and with the short panel, generally this condition satisfy. With the large panel, we will get a violation of this particular assumption. And we know in a large panel, and this one is the one reason why in a large panel we require to use concept of time series econometry. So we'll check there whether data set is stationary or non-stationary. If not stationary, then we need to convert into stationary. In a short panel, generally you have this condition. The third assumption is here you do not specifically assume whether alpha E is random or fixed. So in a random effect model case, earlier in a basic panel, if alpha is not correlated with any of xi, then we go with the random effect model. If alpha is correlated with xi, then fixed effect model one is the appropriate. Okay. And there we assume alpha y1 is the random variable, which one is uh, time invariant variable also remain constant over a period of time. So that kind of specific assumptions, whether it is a random or it is a fixed variable, we do not make in a case of dynamic. But given that given that most of the time in a real situation you find a correlation between alpha I and xi, so you allow for that. So alpha is here correlated with xi. It doesn't mean that you go. It always assume that it is correlated with xi, but we allow alpha I to be correlated with xi here too. Fourth assumption one is expected value of alpha I epsilon it equal to 0. They are assuming that there is no correlation between cross-sectional heterogeneity and idiosyncratic error term. And similarly, expected value of epsilon it given xit and alpha I equal to 0. Okay. So these are the assumptions that we made in case of basic linear panel data regression model also. The distinct assumptions from the basic linear regression model, that one is this one and this one. So there we assume alpha is a random. There we haven't made any assumptions regarding the rho value because there we do not have dependent variable of error term. Sorry, lag value of dependent variable as an explanatory variable. So the problem of this particular regression model is that even if alpha is not correlated with any of xit, the presence of lag value of dependent variable in the model causes endogeneity problem. So earlier in a basic panel data regression case, if alpha is not correlated with xit, then you use random effect model. Okay. So that means there in that case there is no problem of endogeneity. But in a dynamic case, since y I t minus 1 is in the model as an explanatory variable, so having a presence of this particular variable as an explanatory variable causes endogeneity problem. And of course, when we go with the estimation procedure adopted in case of basic panel data regression model, then in that case we get bias and inconsistent estimates. So let's uh, uh, see what happens when we use OLS, pooled OLS I'm talking about, or fixed effect model, random effect model. When we work with it, uh, uh, and when we what happened with the estimates of parameter, or we can say what kind of problem do we face when you use OLS, fixed effect, random effect in a case of dynamic panel data regression model. So as earlier slides uh, suggest us, when we use any of the estimation procedure adopted in a basic panel data, we get bias and inconsistent result, and that one is because of presence of endogeneity. So let's see how the endogeneity remain present in a case of dynamic panel. So, so this one is a regression model. Third regression model I'm talking about, dynamic first autoregressive dynamic panel data regression model. And since this one is a composite error term, which I have denoted here VIT, and in a case of pooled OLS, what we do, we run regression on YIT on XIT. So here, apart from XIT, we are having a YIT minus 1 variable. So when we run this regression model, we find a correlationship between alpha I plus epsilon IT with the YIT minus. And why it is so? So, so for that, if you take a one lag value of the regression equation, so that becomes YIT minus 1 equal to gamma YIT minus 2 plus this term again in a lag form plus alpha I is the constant. So since it's going to remain constant over a period of time, so there is a no loss value of it and lag value of error term. So this one is the composite error term. Now it becomes VIT minus 1. Since VIT minus 1 contains this unobserved error term, sorry, unobserved, we can say the cross-sectional heterogeneity term, and error term in the original regression equation also contains this. And since this one is the related with this one, and here this one is the related with this one, so that means this one is related with this one. So that means that the error term one is related with the lag value of dependent variable, which one is now explanatory variable, and that means regression model suffer with the problem of endogeneity. Am I getting myself clear? Any doubt? So everyone gotten it?
Yes, sir.
Any doubt? No response? Why?
No doubt, sir.
Okay. Because this one is very important to understand why the OLS fails in case of dynamic panel data regression model, even when alpha is not correlated with any of xi. So this means that this result is a departure from earlier result of OLS estimation of random effect model without lag dependent variable. There, uh, without the lag dependent variable as explanatory variable, OLS gave us consistent and if it, though inefficient estimates of parameter. And this one is also a usual departure from the OLS regression model in which we are having YIT minus 1 as a explanatory variable. So again, in that case, we get consistent estimates, though biased in a small sample, given that error term is serially uncorrelated. Now let's move on to the another estimates, which we call fixed effect within estimate. So when we use that, so for using that, what we do, we transform our regression model, subtracting average value of each explanatory variable for each cross-sectional unit. So in that case, we run a regression model YIT minus Y bar on YIT minus 1 minus Y bar YT minus 1, XIT minus X bar, and epsilon IT minus epsilon bar. So again, by constructions, okay, YIT is correlated with epsilon IT. So YT minus 1 is correlated with epsilon IT minus 1 and hence epsilon bar. So since I'm talking about this one, since this one is correlated with this one, and this happens all time because this one is error term and this one is the dependent variable, and we know the error term contains effect of all explanatory variable which have not been included into the model. So that means this one having an effect on this. So this one and this one is related. Similarly, if you run a lagged regression model, so YT minus 1 is related with the epsilon IT minus 1 and Y bar, sorry, epsilon bar is sum of epsilon. So this one is the epsilon bar I. So this one is the IT divided by T. So we can say that YT minus 1 is correlated with epsilon IT minus 1 and epsilon bar. So this one is again correlated with this one. So this implies that if the whole term which one is independent variable correlated with this one, that also means this one is correlated with this one. Are you not getting me? I'm telling about if this one is correlated with this one, so this one is correlated with this one, since and also this one epsilon bar. So since YT minus 1 is related with epsilon bar, so this term is related with this one because epsilon bar is here. So that again means even when we run fixed effect regression model suffer with the endogeneity problem, and given the endogeneity problem, we'll get inconsistent and biased estimates of parameter. We get consistent estimates only when the value of epsilon bar I become very small. especially in relative to epsilon it. So if this in a previous equation, if this becomes 0, let's suppose that relatively as compared to this, okay, if this becomes 0, then we wiped out this, wiped out from the regression equation model, so we only left with this one, and we know that correlation is happening yt minus this with this only. So in that case we do not have a endogeneity problem, but that happen only in a case of large panel, not in a case of, or you can say only happen in a case of long panel, not in a case of short panel. So there is a reference reading for it. That one is by Nickel, which talks more about the irrelevance of y bar I in a long panel case. So we are not going to discuss that in that much of detail. So now let's move on to the another one, which we call the random effect estimator. So you have seen that pooled effect and fixed effect model, sorry, pooled OLS and fixed effect regression model giving us biased result in case of dynamic panel data regression model. Now let's have a look on the random effect estimator. So random effect estimator again give us bias and inconsistent estimates, and it is because the region mentioned in case of fixed effect model. So since random effect model is a linear combination of within and between estimator, so since within estimator giving us bias result, so obviously random effect give us bias result. Now let's move on to the another technique which we call first difference estimator.
Sir,
Yes.
sir, I did not understand the random effect one.
No. Look on this line. Since random estimator is a linear combination of within and between estimator. So if within estimator giving us bias estimate, then of course random effect give us bias estimate.
Sir, which one was within estimator?
Within one is fixed effect.
Fixed effect. Okay.
Fixed effect. Fixed effect model in full called a fixed effect within estimate, or we also call fixed effect within estimator. So there is another way for estimating panel data regression model that we know, and that one is fixed difference estimator. Sorry, cost difference estimator. And this we have discussed initially in case of 2 time period. So in a 2 time period case, we have discussed that both fixed effect model and or you can say fixed effect method and first difference method give us same result. But when t is greater than 2, then we will get a substantially different result from the fixed and first difference methods. So this one is the alternative approach for estimating panel data regression model. So let's see what result, what kind of result this particular estimates give. So in a first difference case, we'll take a difference of each variable from its previous lag value. So the fifth one is the, you can say, the structural regression equation. The lag value of this one is this one, and when we will take a difference, when you subtract 6 from 5, what we get? We get this regression equation. So this we may write this one is delta y, this one will become gamma delta yi t minus 1, and this one is delta xit, and this one is delta epsilon it. So this one is first difference regression equation. So when we use this for estimating panel data regression equation model, again this give us biased and inconsistent estimate, just because this regression model suffered with the problem of endogeneity. So again here you can see that since yt minus 1 is related with epsilon it minus 1, and this one is the part this one is related with this one, so regression model suffer with the endogeneity problem, and we get bias estimate. But there is a solution of it. We know when there is an endogeneity problem, you work with the instrument variable regression, and you use instrument variable method, or we look for an instrument. If you get a suitable instrument, you use that, and that give us unbiased and inconsistent estimates of parameter, and that we studied in our EDA course. That means you have studied about the condition of instrument variable. So there are two important conditions. The one is instrument variable must be correlated with the endogenous variable and not be correlated with the error term. So again in this case, in a dynamic panel data case, we look for an endogenous variable. Sorry, we look for a suitable instrument variable. If you found a suitable instrument variable, then you can use that, and um, get unbiased and consistent estimate. So there is a paper by Anderson and Hasio. So Anderson and Hasio proposed yit minus 2 as an instrument of yt minus 1 minus yt minus 2. Because in a dynamic panel data case, particularly when we are using the first difference regression model, this one is correlated with the error term. Let's go here. Okay. So since this one is correlated with the error term, so in a case if you find a suitable instrument variable for this particular variable, then you can use that and estimate consistent estimates of parameter. So in that case, Anderson and Hasio suggested to use yit minus 2 one as a instrument for this, and according to them it is a valid instrument because yit minus 2 is not correlated with the error term, assuming that yit1 is serially uncorrelated. So if there is no autocorrelation between error term, then yit minus 2 is not correlated with the yit minus 1 minus yit minus 2. Why it is so? Again, go back into the previous one. Epsilon it, one is related with the yit, epsilon yit minus 1 related with the yit minus 1. So if we take yit minus 2 as an instrument, then yit minus 2 one is related with the epsilon it minus 2, but not related with the epsilon it and epsilon it minus 1. And because of this reason, this one is a valid instrument. So it satisfies one condition, and since yit minus 1 is a part of this endogenous variable, so it satisfies other condition also. So yt minus 2 here satisfying both of the conditions. So you can take it as a instrument variable, and that part Anderson and Hasio suggesting to us. and using that we get unbiased and consistent estimates of parameter. Okay. So and this particular method requires at least 3 period of data. So you can't apply with the 2 period of data. But when you will take a 2 period lag, 2 observation already dropped. So we work with the only, in a 3 period case, we work with the only 1 period. More than 3 period case, we work with the more layer of data. Similarly, the alternative way is to use and the second lag value, not second, changes in second lag value as a instrument variable. Which one is the delta y t minus 2. So earlier we have taken y I t minus 2 as a so y I t minus 2 as an instrument variable. We can also take delta y I t minus 2 as a instrument variable. So this become a instrument variable. So in this case, we require at least 4 period of data. There is another paper. Okay, again in this paper, Anderson and Hassius suggest us you will get a more efficient result if you use more of instrument variable. So let's suppose that not in this paper. In this paper, Hassian suggested that if you will get a more efficient estimator using this instrument variable as compared to this one. So that means using a changes in YIT minus 2 one give us more efficient estimate as compared to this one. Given that gamma value is positive. And other x variable are used as it is, so they are instrument for themselves only. And further it says when you use and a more efficient estimation is possible by using additional lag of dependent variable as an instrument. So when you use more instrument, we get better efficient estimates of parameter as compared to using less of instruments. So these are the, you can say, the suggestions from this paper. The drawbacks of this particular test, this tells, and in this paper does not tell us about how many lag of YIT minus 2 or delta YT minus 2 is included into the model. And it further says since more instrument is better, so using a less instrument give us inefficient estimates. But regarding the choice of lag value, so though it is not clearly specified in this particular paper, but we can use AIC and Akai information criteria and Akai information and Schwarz information criteria for checking optimum lag length for instruments. So the next estimator one is the Arlino bond estimator. Okay. So this paper argued that using GMM we get a more efficient result as compared to the just using OLS. Okay. So this paper uses GMM method. Since you haven't covered GMM method, neither in EDA or not going to cover in this course. I do not know about the EDA. Probably you haven't studied this GMM, sorry, DE also. Have you done this one, GBMM?
No, sir.
Generalized method of movement. Okay. In a PhD, we offer Jyoti may teach GMM method. Next time in EDA, probably I will cover GMM method. So this time again, even in this course, I'm not going to cover this one GBM. But you already have to cover many things. So for the time, let's assume that for this particular model, for estimating this panel data regression model, when you use Arduino bond estimator, we rely on GBM method. And so these methods again use first difference regression model, which one is written here as a equation 7. And this method define instrument as like this. So this method again use an instrument, but defining instrument is the different. So when in a case of 1 or 2 time period, there is a no instrument. But with the 3 time period, we define instruments as like this. So for delta yi2, which one is the endogenous variable, okay, the instrument one is yi2. When you are working with the 3 time period. For 4 time period, the instrument for delta yi3 one is yi2 as well as yi1. So the instrument we are defining here in label, and instrumented variable one is in first difference form, or you can say the difference form. It's only different. For delta yi4, the instruments is yi3, yi2, and yi1, and so on. So that means if you are working with the many year of data, then you will use many instruments. Starting with the yi1 till yit minus t. So you use these instruments and estimate regression model using GMM method. Here it is written that what is GMM. So when you use instrument variable method, okay, so in a last semester, in a standard instrument variable case, you use OLS. But as I told you, GMM is also one technique through which we can estimate regression model. So when regression model and when instrument variable satisfy this particular condition which we call exogeneity condition, so that give us unconditional movement condition which we call GMM. Okay. Though not much you are going to discuss in case of GMM, so let's leave this one. So we are not focusing on the method, but we are focusing on this particular estimator which we call Arlino bond estimator for estimating the dynamic panel data regression model. The point to note here is we are using instruments in level, but instrumented variable are in first difference form. So there are two approaches of using Arlino bond estimator. The one is called one step, the another is called two step. So we mainly use two step because that give us efficient estimate. And in a two estimate estimator, we use the residuals of a one step estimator for estimating value of parameter. In Stata, there is a command called xtbond command. You use that for getting the estimates. So this one is xtbond command. As a post estimation, we do Sargent test. This we have done in case of instrument variable also. So this one is the test for over identification of instrument variable. So you do in case of dynamic panel data also. We test for time damage, and if time damage is relevant, we include that. And the literature suggests to always include the time damage in a case of dynamic panel data regression model. But again, this estimator is also not free from the problem. So again, when instrument is weak instrument, we get inefficient result. It again use a less information. So using more information, we'll get better result. And last, which one is the important? Which one is we get imprecise and biased result when the value of autoregressive parameter move towards unity. So the larger the, we can say the row value, greater chances that we get imprecise estimate of parameter in case of Arlino bond estimator. So the question arises, what the solution? So literature suggests us to use system GMM instead of GMM only. So one is the GMM which you use in case of Arlino bond, the another is called the system GMM. So system GMM is not in this course. I am not going to cover this one, but always remember this one gives us a better result as compared to the Arlino bond estimator. So there is a lot of research on this system GMM. Okay. When we actually work with the dynamic panel data in future, so at that time, just remember there is a one method which one is we consider as a improved method on Arlino bond estimator. So our discussion is up to Arlino bond estimator only. These are the suggested reference reading. Important one is the Cameron and Trivedi. So that this lecture note largely rely on this particular book only. Page number is mentioned here. We also complement this reading with the Ullrich. And the third reading one is microeconometrics with Stata that we will do cover when we work with the practical exercise on dynamic panel data regression model that we do on Wednesday. So this much for today, and this much in theoretical discussion on panel data regression model. So any doubt? We already 4:18. I'm going to stop